Hi, this is Maggie. In this video we're going to talk about keeping a sprite from walking over or through elements of the terrain by detecting collisions. This is a simple Sprite Motion program called class-.py. It is simple because the sprite moves at a constant speed in only one of four directions: up, down, left, or right. The same principles that we will see here apply with vector motion, but the calculations are just a tiny bit more involved. Your text has an example with vector motion. In this program, the sprite's update method adjusts the sprite's location and boundary checks the four sides of the screen. Suppose we want to add some terrain that the sprite cannot walk over, such as a building or a fountain or a statue. I'm going to create a building sprite. And this will be of the quite simple sit on the screen and do nothing variety. I'll rename this program to class-building.py and add a building class. Which will simply consist of an initializer that takes an image and location as parameters, sets the image and rect fields, and locates the image at the location passed. Down in the main program, I'll annotate a building sprite and a group for the building, and I'll clear update and draw that group. And I'm going to do that after the student group. And it's true, we don't need to update that building. I like to leave it in case I decide to modify the program. Maybe we want to animate the building at random intervals, open a door, throw a party on the roof, toss a computer out a window. Okay, and we'll run that. And there's the building in the middle of the screen, roughly. And student can run right under the building, which may be the desired effect. I like that shadow of the building is cast over the student if the student runs next to the building. But this video is about preventing the student from running under or over the building, and rather responding to a collision between the student and the building. And maybe we do want to respond by opening a door and switching to another screen in which the student is in the building. But here I just want to prevent the student from running into the building. So either they stop or they bump. So how this works will depend on your sprite and what directions your sprite can move and how exactly you're handling the motion. In this game, arrow keys change the sprite's direction. It can move only up, down, left, or right, and not combinations. Releasing all arrow keys results in the sprite stopping. This is handled with two methods of the sprite. A move method, which sets the dx and the dy based on the direction of motion, and then the update method, which actually moves the sprites and checks the boundaries. And the way I'm going to solve the problem in this program is a little different from the example in the text. Again, how you solve this will depend on your game. The way I'm going to handle this is to pass the building group into the student's update method so that it can check for collisions, not only with the screen, but also with the building. So I add that argument into the call, and then up in update, I'll add it to the parameter list. And within update, I'll add self.dy and self.dx to the rect, and then I'll write while pygame.sprite.Sprite collide, and I'll pass in self. Self is the student sprite, and then the buildings group, and then I'll use collide mask because my building is a weird shape. And while there's a collision, I'll have the sprite back up. So I'll set a variable dx to negative self.dx times 2. And the same for dy. And then I'll add dx and dy to the rect. This will bounce the sprite away from the building if it collides. This works great until I rotate the sprite. So if you have a symmetrical sprite that has exactly the same containing rectangle when rotated, this would work. But if I can get this sprite close enough to the building and stop moving it, and then try to turn the sprite, it jumps. And it jumps because, think about what's going on. I had a self.dx and a self.dy of 0 because I had stopped, and the sprite wasn't touching the building. Then I tell it to go up. So self.dx would be set to 0, and self.dy would be set to negative speed in the move method. and the sprite is rotated to face up, and it now collides with the building. And so it's backing up, but it's backing up in the new direction. So it's going to slide along the building backwards until it stops colliding with it at the bottom. The user never sees this because I have that backing up in a loop in the update method. Here's what's critical. If you want to solve problems like this, you really need to understand what's causing them. And at first, they might be baffling because you think you've thought of everything, and many times your program works just fine. And then suddenly, you try to move up, and your sprite's below the bottom of the building. So you need to be methodical. Test one thing at a time until you figure out what works and what's broken. Only once you've explored every last corner of the bug should you make a conjecture about what's causing it and try to solve it. Do not try to change the code before you've figured out the underlying cause of the bug, or you may as well turn your program over to your pet to fix. I discovered that I could crash into the building and move toward or away from it. In other words, up and down if I crashed into it, moving up or down, or left or right if I crashed into it, moving left or right, and there was no problem. But if I crashed moving right and then tried to move up, the sprite jumped. I have to figure out what in my code is causing that, but I also need to figure out what about turning the sprite is causing that. So, how do I solve this? Well, the problem is with rotating the sprite. So what I need to do is rotate the sprite, and then, if it's colliding with a building, move it backward again. But I need to move it backward from the last direction that it was moving. So if it was moving right, then I rotate it to move up, and it intersects with the building, then I need to move left. That shouldn't be a problem if I check before I change the dx and the dy, unless the sprite has stopped. Then dx and dy are 0, and backing up won't work, because I've lost that last direction information. To solve this, I'm going to add some fields to the sprite. self.lastDx and self.lastDy. And I'm going to have to initialize them in init. And then I need to both check them and maintain them. So in the move method, I'm going to need to rotate first. After I rotate the sprite, I'm going to have code similar to the code in update, a loop that backs the sprite up if it's intersecting with building. This means I need to send the group of buildings to the move method. Okay, so I'll use a loop, but if the sprite has stopped, I need to use the last dx and the last dy. And I know the sprite has stopped if its dx and dy are 0. And if the sprite has not stopped, then I'll just back it up by its dx and dy multiplied by 2 to be consistent with update. And then the other thing I need to do here is maintain the last dx and last dy, and I'll do that before I change dx and dy. If they're not both 0, in other words, if the sprite was moving when the user decided to either stop or move in a different direction, resulting in this method being called, then I'll set the last dx and last dy to the current. Okay, but that should hopefully do it. I'm going to pause the video and look this over, and then come back. Okay, and I forgot to pass buildings in to the move methods, the building group. I'll add that in. Okay, and again, this is class-building, and I'm going to run it and test the student running into the building. And if I get really close to the building and stop, which is what was causing the error before, and then try to turn and move, it works fine. The student backs away from the building a tiny bit and moves in the new direction. So that is an approach to collision detection with terrain, and it was rocky in a few places, but by careful testing, you can figure out what is causing the errors and write some code that is fairly consistent and easy to read, and that works well. Easier code would have a symmetrical sprite, or a sprite that doesn't rotate at all, and fewer directions of motion. But it's entirely possible to write more complex motion. You just don't want your code to get too convoluted. So I recommend you try recreating this. Maybe start with a symmetrical sprite, since it's easier. You could make a sprite that's simply a square or a circle. When you can recreate this example, you're ready to move on.